Lesson 8-3, scale drawings, and in this lesson you learn to find the actual length from a scale drawing. When am I ever going to use this? Knowing how to find actual length from a scale drawing can help you determine mileage between cities on a map. Okay? Keyword that we are going to talk about is scale drawing. So one of the largest meat-eating dinosaurs to have ever lived was the Tyrannosaurus rex. Since it would be difficult to draw the dinosaur's actual size, you can make a scale drawing. Definition of a scale drawing shows how an object exactly as it looks, okay, but it is generally larger or smaller. Okay, so that's the definition of our scale drawing. It shows an object exactly how it looks, but it's generally smaller or larger. Okay, so the scale gives the ratio that compares the lengths on the drawings to the actual lengths of the object. Okay, and let's see how this is done. Suppose a drawing of a dinosaur had a scale of 1 inch equals 20 feet. Okay, if the length of the dinosaur on the drawing is 2 inches, what is its actual length? Okay, so you have a scale on the dinosaur that every inch in that drawing will be equal 20 feet, 20 actual feet. Okay, so the question is, if the length of the dinosaur on the drawing is 2 inches, what will be its actual length? Okay, now let's take a look at this study hint. Reading math, the scale 1 inch to 20 feet can be read as 1 inch is equivalent to 20 feet. So that's another way of looking at it. So that for every inch, the equivalent length of every inch is 20 feet. Okay? And let's see how we can do this. Okay? You can write a proportion to find the actual length L. Okay, so our scale, start off here, our scale, okay, will be length in drawing, which is 1 inch, we talked about that, over actual length, which is 20 feet. That's our scale. Okay, our dinosaur, on the other hand, okay, will be the drawing, okay, which is 2 inches, and we want to find the actual length in feet of our dinosaur. So if you notice, this particular ratio, okay, involves our scale, and this particular ratio involves our dinosaur. Okay, now if you also notice, okay, the length of the drawing and the length of the drawing on the scale and the length of the drawing the dinosaur are both in the numerator side, and the actual lengths of the scale and the dinosaur are both in the denominator side. So this is one way, okay, to organize your ratio so you can get the actual length. So after we have created our portion, okay, we do what we did in the last lesson, which is we get the cross products. Okay, so 1 times L is equal to 2 times 20, and and therefore L equals 40. That means that the actual length, okay, of the dinosaur was 40 feet, or 480 inches if you want to convert this into feet. Okay, knowing that, let's take a look at example 1. Suppose a drawing of a dinosaur at a scale of 1 inch equals 18 feet, meaning for every inch in the drawing, its actual length is actually 18 feet. Okay, if the height of the dinosaur at the hips, okay, is 1/2 inch, what is the actual height at the hips? So again, we go back to our scale. Before we do that, I'm sorry, we need to create a let statement. Let H represent the height of the dinosaur at the hips, and we want to write and solve a proportion. So we have our scale on one side, and we have the dinosaur on the other side. So this particular ratio right here will deal with the scale, and this ratio would deal with the denominator. So length of the drawing is 1 inch, and actual length is 18 feet. That's our scale. So in the dinosaur, we know that the length of the drawings is 1/2 inch, but we don't know the actual length, which is now h feet. So we'll create our cross products. 1 times h equals 18 times 18 times 1/2. 1 times h is simply h, so we're left with h equals 9. Okay, so the height of the dinosaur, the height of the dinosaur at the hips is 9 feet or 108 inches. Okay, before we go to example number 2, the secret word for this particular lesson would be Manning. The secret word will be Manning. Okay, as in Peyton Manning. So let's take a look at example number 2. History: in 1936, a meat company first produced a vehicle shaped like a hot dog. The 1995 version of the vehicle is 8 feet wide and 27 feet long. If a scale model of the vehicle is built with a width of 4 inches, what will be its length? So again, we're given the length and the width of the vehicle, the actual length and width of the vehicle, okay, and the actual width is 8 feet and the actual length is 27 feet. We want to find, okay, the scale or the scale model length of the vehicle given the width of 4 inches. So again, just like the dinosaur, we have a let statement. Let L represent the length of the model, and we write and solve a proportion. Okay, so this is our model on the left side of our proportion, and on the right side will be the actual vehicle. So we know that the width of the vehicle is 4 inches, it's given, and the length of the vehicle is 8 feet. Okay, we know also that the actual length of the vehicle, okay, actual length of the vehicle is 27 feet, okay, and the length of the model is 27 inches. Okay, so after that proportion has been created, okay, again, this side of the proportion indicates our model, okay, and on the right side indicates the actual vehicle, and the numerator side, okay, we talk about the actual width of the model, the width of the model, okay, and the actual width, which is equal to 8 feet. Okay, so if you look at our scale here, our scale is for every 4 inches. 4 inches, it'll be equal to 8 feet. Okay, this, when you talk about model, this is basically the same as the scale. Okay, and just like in our previous example, let me erase that to make my line thinner. This is actually our scale. Okay, okay, so with that, we create our proportion and we do cross products. So this becomes 4 times 27 is equal to 8 times L. Okay, after that we get 108, which is the product of 4 times 27, and that is 8L. And then we solve for L by dividing both sides by 8, end up with L equals 13.5. Okay, so the length is 13.5. The length of the model is 13.5 inches, or 1 and 1/2 feet. Okay, and this is your hot dog mobile. Okay, they actually called it the Wiener Mobile. Okay, and that's the end of our lesson. Thank you for watching.